I did the quiz 2 remake, and the problem involved looking at finding the value of p for which the sum converges. So as we look at the problem, we can obviously see that this would be considered a p-series test because of the identifier of the p in the exponent. So when you're talking about the p-series test, you need to understand that if k is greater than 0, which in this case it's 2, so it's greater than 0, then the series converges if p is greater than 1 according to the p-series test. To find out whether or not this problem converges and if p is greater than 1, we need to use the comparison test. So by looking at the initial problem, we can look at the comparison test to see whether or not p will converge. So by changing the problem to compare which one is larger, we took out the k and kept it into the form of 1 over the natural log of k to the p. So when we look at, as we compare the two and denote them as a and b, you can tell that a is less than b due to the fact that the denominator is larger in this case, whereas because k is being multiplied, making the denominator larger. By making the denominator larger, the overall fraction is bigger because of the fact that it's continually getting smaller. So it was like 1 over 5, then 1 over 6, 1 over 7. But on this side, the denominator is smaller in comparison to this, making the overall fraction larger. So we now know that this side is larger than that side, so we can now check to see whether the larger function is converging. So we would now look at the denominator for the the larger function, and see that if the denominator will continue to keep increasing as you keep adding exponents, so that means the overall fraction is getting smaller as it converges closer to 0. So now that we know that the larger function b is converging, we now know that the smaller function is also as well converging. And we now know that p is greater than 1 is converging here, so we know that p converges when it's greater than 1.